Okay, hello everyone, and welcome back to another episode of Power Logic. So today we're going to be doing the 2022 Aime Ii problem 11. Let ABCD be a convex quadrilateral with AB equals to 2, AD equals to 7, and CD is equal to 3, such that the bisectors of acute angles, angle DAB and angle ADC, intersect at the midpoint of BC. Find the square of area of ABCD. So first, we're going to just start drawing a diagram. Let's say our quadrilateral looks something like this. Now if I expand this diagram, then these two are the angle bisectors, and these two are equal. So now we're going to label the length. So we have AB is equal to 2, AD equals to 7, and CD is equal to 3. I think if I didn't, yeah. So this is a quadrilateral that we actually, okay, sorry. So this is actually the quadrilateral that we wanted. Now, we want to find the square of area of ABCD. This is such a little amount of condition that we have. However, it's in the problem statement that this is the angle bisector, although my diagram doesn't really look like. Although my diagram doesn't really look like it, but this is indeed the angle bisector. So now, in a triangle, the three angle bisectors actually intersect at a common point, and this is known as the incenter. The point is called the incenter. So incenter is the center of the circle that's inscribed inside the triangle. So therefore, this motivates us to probably extend these two lines. Draw an extension of these two lines. Well, this doesn't look really a good diagram. You know, it's actually really hard to just draw a good diagram. Okay, so we're good with this. So now if we just call the point that intersect, we just call this point to be P. Now, because this midpoint, we're just going to call this point to be M. So this point is actually the intersection of the two angle bisectors, and therefore it must also intersect with the third angle bisector, which is this. So these two angles are congruent. So let's call this to be M, then the angle BPM is congruent to angle CPM. Now, although this doesn't really look like the case, but let's focus on this triangle and this triangle. Now, M is the midpoint of BC, and M is also the angle lies on the angle bisector of angle BPC. this basically means that these two are actually right angles, right? So these two are just a right angle. And this basically tells us that AB is the same length as, no, BP is the same length as PC. Now I just realized that I forgot to write all the side length, but it's still not too late. So now what to do next? We still cannot use any of the side length that we have. So now we're gonna do like a little bit of angle chasing. So we call this to be alpha, and this is also alpha. Call this to be beta, and this is also beta. Now this angle right here, this angle is just 180 minus alpha minus beta. Now we can clearly find this angle right over here by just doing angle chasing on triangle BPM, which should be not hard. So let's call this to be var phi. Then var phi is going to be equal to 180 minus 2 beta minus 2 alpha divided by 2, which is 90 minus alpha minus beta. So var phi is equal to 90 minus alpha minus beta. Now angle, oopsies. Now angle PBC is actually equal to 90 minus var phi, which is equal to alpha plus beta. So this the same as, and this is actually the same as angle PCB, since this entire triangle is isosceles. So now we have this bunch of equality conditions. Now we can deduce that these two angles are the same, and they're actually just equal to 180 minus this. So now we actually get to the point to conclude that this angle is alpha and this angle is beta. Okay, this is a really great observation because this means that these two triangles, this triangle right here and this triangle right here, they're indeed similar triangles. And BC is equal to, and BM is equal to CM. Now, this basically tells us 2 over BM is equal to CM over 3, but BM is equal to CM. So this gives us BM equals to CM equals to under root 6. So BM is equal to CM, and they're both under root 6. So now what? Now we know that they're both under root 6. So now, what do we do? Well, we still did not use the condition when AD is equal to 7. Now we can actually just consider the angle APD. So now apparently both of this triangle, this large triangle, and the smaller triangle contains the angle APD. So now we can just break out the law of cosine, since we know that we can just set this line. We'll just let BP equal to x and PC is also equal to x. So now we can just set law of cosines to be equal. Set equal, we're going to have the left angle is going to be 2x squared minus 2 root 6 squared and divide by 2x squared. Now, the right side is going to equal to x plus 2, x plus times x plus 3, and then the top is going to be x plus 2 squared plus x plus 3 squared minus 7 squared. So these two are just indeed equal, and now the calculation doesn't seem to be friendly, but obviously we still have to do it. So we're just going to be proceeding. So now we're going to cancel out the x. So x squared minus 12 over x squared is equal to x squared, 2x squared plus 4 plus 6x plus 13 minus 49, and then entire thing divided by x plus 2 times x plus 3. So this one is just equal to 2x squared plus 10x minus 36 over entire thing over x plus 2 times x plus 3. Now, this still seems to be like a lot because we probably is going to have a quartic. Now we can actually reduce this to be 1 minus 12 over x squared, and this is just equals to x squared plus 5x plus 6 minus 3x squared plus 15x plus 42. Hopefully I didn't make any of the calculations. So this is essentially just equal to 1 minus, well, you know what? Let's just skip this step. Just multiply it out. Okay. There's a 2 here, so this is probably why. Okay, I think I kind of messed up the calculation. So we can also cancel out 2. They're going to have x squared minus 12 over x squared is going to be equal to x squared plus 5x 18 divided by x squared plus 5x plus 6. So now we just rewrite both sides as 1 minus 12 over x squared is equal to 1 minus 24 over x squared plus 5x plus 6. So 1 cancels, so, and then we can also cancel the 2. So 2x squared we'll do x squared plus 5x plus 6. So x squared minus 5x minus 6 is equal to 0. So now we can actually just factor this. But well, we cannot have this to be 0, so x is equal to 6. Now let's just plug it back into the diagram. We're going to see that this part is equal to 6. So if this is 6, then we can just use the sine area formula. Sine area formula gives that A is equal to 1/2 times AB times sine of theta. For such triangle, if this is theta, this is A, and this is B. So the area we want to find is equal to 1/2 times sine theta is just equal to √6 over 6. No, wait, no, it's not. Sine of alpha is, so there are two roots, there are 2 6 and then 1 2 √6. So 72 minus 24 over 2 times 6 times 6, 2/3. Now we're going to have 6 plus 2 times 6 plus 3. 8 times 9. Wait, so cosine is, is 2/3, so sine is going to be the square root of 5/3. 8 times 9 minus 6 squared. This is equal to 1/6 times 36 times the square root of 5, which is equal to 6√5, which is under root 180. So keep in mind that what we want to find is the square of the area. So therefore, our answer is just equal to 180, and we are done. Thank you for watching. Hope you enjoyed, and I hope to see you in the next video.